Hey y'all, let's do lesson 6. Yahoo! Yeah! Lesson 6 is about truth tables. Now I want to start by clearing up a common misconception. What is a truth table? Well, let's start with what a truth table is not. A truth table is not a place where Wonder Woman eats lunch. A truth table is a pretty handy way of looking at a conditional statement and figuring out when it's true and when it's not. Now the first two columns of a truth table are always going to be the same because your hypothesis P can either be true or false. When the hypothesis is true, the conclusion can either be true or false. So here's where the hypothesis is true and the conclusion are true. So next we could have the hypothesis be true and the conclusion be false. Or we could have the hypothesis be false and the conclusion might be true. Or the hypothesis is false and the conclusion is also false. Now I'm going to let you inside and I'm going to not use all the mathy words for a second. And I'm going to tell you there's only one way for a conditional statement to be false. The only time a conditional statement can be false is if you have a true hypothesis pointing to a false conclusion. Another way to say almost the same thing is that if the hypothesis is false, then the entire statement is true. The conditional statement is true no matter what the conclusion is. And that might seem weird to wrap your head around at first, and mathematicians argue all the time about what's the best way to explain that. And in order to not melt your brain, because we're just in like geometry you're not in your college logic class, just remember this. Conditional statement can only be false if you got a true implies false. Or always remember that anytime the hypothesis is false, the whole statement is true. Alright, so here's the typed up official version of what I just said. And now let's look at our truth table. This is like the result of our truth table. The first two columns, I don't remember if I said this already, but the first two columns of a truth table are always going to be this. It's always going to be P, true, true, false, false, Q, true, false, true, false. That's always how we start. And then we use that to figure out the truth values of whatever other stuff we're looking at. So P implies Q. True implies true. Well, does that break any one of these ones? No, so this is going to be true, right? So a true statement implying a true statement, that's a true statement. A true statement implying a false conclusion, remember that's the only time that a conditional statement is false. A false statement implying a true statement, that statement is always true. And we are just going to live with that. And look at our notes when we don't remember. And then the bottom one, false implies false, that's always going to be true as well. So if you can remember these two guys right here, if the hypothesis is false, you can skip that and you know the whole statement's true. The only way to get a false conclusion for a conditional statement is if you have a true hypothesis pointing to a false conclusion. So we say that Stu Tatements. Hi, my name is Stu Tatements. We say that two statements are logically equivalent when they have the same truth table. And we'll look at some examples of that momentarily. So example 6 is about making a truth table. So we are going to use the truth table that we just made. Remember, right here. We're going to use this one to make truth tables for the converse, inverse, and contrapositive of a random conditional statement P implies Q. So let us start with the converse. So the converse is Q implies P. So now we're going to start with Q and go, this is now my hypothesis and that's my conclusion. So true implies true is true. False implies true. Remember, this is now our false hypothesis. So it doesn't matter what our new conclusion is. The whole statement is true. True implies false. Remember, that's the only one that we should like get a red light that says, ding, we got a true thing, a true hypothesis trying to point to a false conclusion, that is a false statement. And then false implying anything is true. So false implies false is true, false implies true is true. So here is the truth table for the converse of P implies Q. Let us look at the inverse. The inverse is not P implies not Q. So we need to make columns for not P and not Q in order to be able to keep track of all this logic. So if P is true, then not P is false, right? Because if it's not true, then it's false. If Q is true, then not Q is false. So basically, these two columns are going to be the opposites of these two columns, right? If P is true, not P is... Oh, timeout. I went the wrong way. Let's look at not P implies not Q at this point. So not P implies not Q. We have false implying false. And anytime we have a false hypothesis, the statement is true. So now when P is true, not P is false. When Q is false, not P is true. False implies true. Remember, anytime the hypothesis is false, you can say whatever you want after that, and your statement is then true. So I could say, if Britney Spears is the president, then I'm a bazillionaire. And I just made a true statement, even though I'm really not a bazillionaire, because a bazillionaire is a fake word. And I'm not rich. All right, let's look. When P is false, not P is true. When Q is true, not Q is false. So not P implies not Q would mean we have a true implying a false, and that makes the whole statement false, right? We can't have true implies false. And last one, when P is false, not P is true. When Q is false, not Q is true. True implies true is true. And then one more, the contrapositive. I'm telling you, that would be a cool rap name. Math nerds would get it anyway. All right, so the contrapositive is not Q implies not P. So, not Q, right here we would have, so if Q is true, then not Q is false. If P is true, then not P is false. False implies false. False implies anything is true. When Q is false, not Q is true. When P is true, not P is false. True implies false is our only way to get a false statement. When Q is true, not Q is false. When P is true, not P, when P is false, not P is true. False implies true. False implies anything is a true statement. And now these are both false, so these are going to be both true. True implies true is true. True dat. Okay, now remember on the last slide when I said two statements are logical equivalents if they have the same truth table? Check out the conditional, the original conditional, and the contrapositive. They have the same truth table. That means that these two statements are logical equivalents. Remember this from lesson 3. The conditional and the contrapositive are logical equivalents. So if today's Thanksgiving Day, then it's the month of November. That's true. If it is not the month of November, then today is not Thanksgiving Day. That's true. They got the same truth value. They have the same truth table, in fact, and so do the converse and inverse, as you can see right here. True, true, false, true. True, true, false, true. All right. Now let's do an example of making a truth table for the conditional statement P implies not Q. So remember, the first two columns of a truth table are always the same. The P, TTFF, and then the Q is TFTF. Now we need to do not Q so that we can figure out P implies not Q. So not Q is going to be the opposite of Q. So will be false. Oops, false, true, false, true. All right, so now we're looking at P implies not Q. So true implies false. That's our alarm, right? True implies false is a false statement. True implies true is true. False implies false. Well, false implies anything is true. And false implies true. That's also true. So FTTT is the truth table for P implies not Q. You're an amazing person. You remind me of, like, you're so cool. You remind me of the time that I was hanging out with Shaq on a roller coaster. Thumbs up, dude. Rock on.
Hey man, this is Shaquille O'Neal. I love Mr. McWhorter.